Okay, so in the last video we looked at prime and composite numbers. And in the one before that, we looked at divisibility theories. And in the divisibility theories, we discussed the fact that this A/B meant that A was a factor of B. Okay? And all that means is that B can be divided by A. That's what a factor means. And so when we're looking at numbers and composite numbers, I said they can be expressed in their prime factors, and we talk about that as being expressed as a product of their primes. Now, here's a proof that shows that all numbers can be expressed as a product of their primes. And it also gives us the first step in working out what prime to look at. So, if A is equal to P times Q, and P is less than or equal to Q, then 1 is less than P, and P is less than or equal to Q, which is less than A. Now, if P is less than or equal to Q, then P squared is less than or equal to PQ. Because if P was equal to Q, then P squared would be P times Q. And if P is less than Q, then P squared has to be less than PQ. Therefore, P squared is less than or equal to A. And A is our composite number in this situation. And if we take the square root of both, we get negative root A is less than or equal to P, which is less than or equal to root A, or square root A. And that's because whether it's the negative or the positive root, it is still going to be the same number at the end of the day. The square root of 4 is either negative 2 or 2. Because negative 2 times negative 2 equals 4, and 2 times 2 equals 4. So, therefore, negative 2 squared equals 4, and 2 squared equals 4. So when we're discussing the square root of something, we can have plus minus the square root of 4. So with that, if we get that negative root A is less than or equal to P, which is less than or equal to root A, but 1 is less than P, then 1 is less than or equal to P, which is less than or equal to root A. Now this might seem really complicated, and it is as a proof. It proves the theory. All it means is to find the prime factors of a number, we need to test primes up to the value of the square root. And we're going to give an example right now. Let's take the number 399. If I want to find the prime factors of this number, I take the square root of 399, which equals 19.9 and a bunch of other numbers after it. And this tells me to test the primes up to 19. And so then I'll go and I'll list out my prime numbers up to 19, and I'll have 2, 3, 5, 7, 11, 13, 17, and 19. And I like to work backwards. So then I'll take my 399 and I'll divide that by 19, which gives me 21. So I can then say, okay, 19 is one of my factors. Then 21 divided by, we'll go 7, another number it can be divided by, equals 3. So I can then also say, okay, if 399 divided 19 is 21, and 21 divided 7 is 3, then 3 and 7 are also prime factors. Because, if you remember, if A is a factor of B, and B is a factor of C, sorry. B is a factor of C, D would work, but we'll go with C. Then A is a factor of C. And 21, sorry, is a factor of 399. And 7 is a factor of 21, just for one example, then 7 must be a factor of 399. And it's the same for 19 and 3. That's one example.